Okay, so I posted a simple video before of trying to sketch this Coriolis effect when you are moving east-west as opposed to north-south, which is not so intuitive. And obviously that was not a very good quality video. And then after I posted it, I have two scary friends, KK and Vineet, who subscribed to the channel, and these guys are super critical. So you have to be careful what you do with your postings, right? So I went and did some research and I found this thing called Sketchpad, which can allow me to draw. So let me try to redo this sketch of the east-west thing. So what are we trying to do? We are basically trying to see on Earth if you are trying to move east to west. Okay, so that's some latitude, let's say theta, and the equator is here, and you are trying to move east to west or west to east or east to west, then why should you be deflected to the right in the northern hemisphere? And I had said this is something to do with the centrifugal force, right? So here is the axis around which you are rotating, and you are going happily along this latitude circle. And all the time when you move on a rotating framework, you have this centrifugal force that's trying to throw you out. So it's like the merry-go-round. If you let go, you're going to fly off, right? So that's how you would fly off. So this centrifugal force actually has a component that points towards the center of the earth and a component that is horizontal. Okay, that is my arrow, which hopefully is acceptable to these guys who are going to shout at me. And so this vertical component, as I said, pointing towards the center of the earth, is it's just in the direction of gravity. So when it's pointing down like this, it would actually, it should be pointing up, shouldn't it? So it would be reducing or increasing gravity, but as I said before, this is very, very small. It's only about 1,000th of the actual acceleration due to gravity that we have from Earth. But this horizontal component is actually still enough to create this deflection to the right when you move at large enough scales. As I said in the other sketch, you can also use this to see that if you're moving along the equator, then the centrifugal force has no component other than pointing towards gravity, because on the equator you have no deflection, no Coriolis effect. Coriolis effect is zero on the equator, increases with latitude, and its maximum at the poles. Okay, so this is something you have to remember. The animation we saw about launching rockets full of chocolate from the north to south, or from south to north, you will see that the way the speed of Earth's rotation in the tangential direction changes is not linear, so the Coriolis effect deflects things more at higher latitudes than at lower latitudes, and it goes to zero on the equator. This becomes very critical actually later on, as we will see that when water is being pulled by the atmosphere at higher latitudes versus lower latitudes, the deflection to the right in the northern hemisphere and to the left in the southern hemisphere actually depends on at what latitude water or air is moving. So Coriolis effect is not constant. We will add another complication later on called vorticity, but let's not get into that right now. So this is the re-attempted sketch, which we don't know will make KK and Vineet happy or not, but nonetheless, I think it's better than what I did before, right? The other one was not done very well, but nonetheless, I will leave it on so you can compare to see how much I improved in this same day.